Can I go ahead, Tochukwu?
Yes, sure.
Okay. So, good. Okay, good evening, everybody. So, we'll do a quick recap for the part we did last week, Saturday, since it was a bit confusing. So, we'll just quickly brush the initial part. There's no need to go over the introduction again. So, just for us to understand what Bash is, and then we go into Bash programming. Bash is for automation for the sake of reproducibility and integration. Is efficient and is good when it comes to handling errors. So for the variables and the input, okay, we already established that variables are used to store data. So you can think of variables as maybe like boxes that are used for storing information, maybe names or numbers, or maybe paths to specific places in your system. And so we have rules that you use, so you don't make use of um it's good to make use of lowercase letters when you're doing that. And you must start with a letter, but we found out that we can actually start with an underscore. It's just you can't start with a hyphen. And so you can also use underscores to separate words. You don't do something like chapter number equals 5. There's no spacing when you want to assign a variable or assign items into a variable. So either you use your space, use underscore as your space, and make sure that there are no spaces in between the equal sign, even within your variable name as well. So and then we tried seeing how that works using bash. And you set, so what happens is you set the variable by calling the name and then the item you want to put into it. So in this case, we had bioinfo UI. And so you access your variable with with the dollar sign. So if you want to, if you, let's say the name is bioinfo UI, right? And if you want to call it, say echo hello name. So, okay, let's just quickly see how that uh, plays out here. So your variable, you have name equals, I don't know, right? And so if you want to call your variable, access it, you have to make use of the dollar sign, and then you call the variable name that you used. So that would do that. And then we also saw how, okay, for more examples on variables, when you have a number, you can actually perform arithmetic operations. For example, when you make use of the command let. So if say let equals to number is the variable name, and then we put a number. So you say let number be equal to the variable name you already defined, and then you do the arithmetic operation that you want to do. So you now call it out by calling number. I guess it's important to say that if you assign a variable name or an item to a variable, so if I say echo and I echo number, right, it gives me 6. So if you change the item inside, it's rewrite. So if I go again and say number equals to 7, and I say it's echo number, it gives me 7. So it's only when maybe when you do bash scripting, you may get this idea better. But for the let now, so let number equal to what was assigned number before. So this dollar number here is for the last assigned, which is 7. I'm just trying to give more examples in case that you can overwrite what is in your variable. Then you use +3, and then you echo number now. You get the addition. So it's not like you put something in your variable, now expect it to be the same when you now use another name. Like if I now we know that name is oh, name is this. So if you go ahead again to change what name is, right, and you echo name, it changes. So it will write. So and then we have command substitution. So what happens in this case is that um, you are telling it to perform this function, and then it gets assigned. So the bracket is to hold it together so that whatever is the output for this WC, like word count, how many lines are in file.sh, I got this commanders. So whatever the answer is, it puts it into lines. Because if you just do, let's see what files I have here. So if you just do let me see what is in demo. Okay. So if I want to count if I want to count the number of lines that is in demo, okay, it's 10. So it just puts the output here. But by the time I do lines, okay, and I do lines equal to dollar WC demograph. So the answer has been imputed. The result for this command has been kept into the as line. So if I tell it to echo lines, it's going. So what the only difference between these two is that you can, if you are performing a, how do I use this now? Okay, if you're going through a chain, maybe in the pipeline. Okay, pipeline is how you try to analyze or process things in bioinformatics, and then you want the results of a particular analysis you run, maybe QC, to check the nature of your command, like you want to check if it's compile, if it's valid, or if it's maybe there's an error. Maybe you run fast QC, and then after fast QC you can have like, oh, okay, if it meets a certain criteria, you can now move it to the next command and tell it to do Trimomatic or to check the adapters or something like that. So in this case, whatever you do, just printing out here, it will just give you the results on the screen. It doesn't store it. So, and then for when you put into a variable, basically you are storing the information that you get. So for, okay, and then we have script arguments. Okay, so when you're trying to, you make use of arguments when you're trying to assess what is inside your maybe your variable or your array. So let me just give an example. Okay, so we have a script that okay, let's do it like this. So we have, let me create a script nano argument. So you will learn proper scripting when we do bash scripting. So I just want to create a script so you understand a bit of what is having bash. Okay, so echo plus its name $0. Okay, and then echo, let's say the first argument. Echo second argument $2 and yes. Okay, let me just do all of them at once. Number of arguments. I just shorten it. So dollar and then echo all arguments, all args. Args. And then okay, let me just add echo. You gave a certain number of arguments, and then these are the arguments. Okay, so let me save it. So if you are trying to run a script, either you type bash outrightly and then the name of the script. Okay, it's not executable yet, so text as okay. So let me run the script, and let's say I want to explain the argument function. So let's say args with sh, and I want to make it apple banana lemon, and I run it. So the first command in the script, is there where I want to open the two side by side so that I can be showing you the script and at the same time. Okay. So in my script, I said echo the script name. So that will be the first argument. I mean the first argument, which is from what I typed here. That is this the first item in what I that's the args example.sh. Basically the script's name. This dot slash is not there. It was what I used to call let me use bash. Should I soon get confused? Okay, I know. So the command here says echo script name. So you take the first item. The indexing when it comes to programming starts from 0. So the first item is 0, the second item is 1, the third item is 2, like that. So the first is to take the script name, call it out. So echo. So what's the first argument? That would be the apple, which is the next thing, and then we have the second being banana. And so when you want to know the number of items in your variable, or let's say in your array, is an array in your array, so you use the dollar hash sign, which is used to it will count everything 1, 2, 3, and then gives you the result. And then if you want to tell it to call all the items, and it will call everything. It's called the apple, the banana, the lemon. And so the final is you give, of course, a certain number of arguments, and then it wants you to print it. So this is basically you gave, it tells you the number of arguments that you gave, and then it also tells you, it also lists. So this at $@ now prints everything, all the arguments that you gave. So that's why we have, you gave 3 arguments, right? This is the script name. You gave 3 arguments, and then it lists, it goes ahead to list it. So I hope that's a bit clear or clearer. So yes. And then we have 2 ways you can get input. So one of the ways you can get input is what I just did by making use of arguments, where in front of the script you give it arguments, so that you give it argument, so it's passed when the script is run. Or you use the user prompt with read. We also used an example of that where we had okay, let's say the script now. Let's create a nano read example script, the message to the user being, and then I say read, right? P so enter your favorite color, or favorite sequencing technology. Okay, and then you give it a variable name. So let's call it tech. And then you now tell it to echo something like great, and then call on the variable that the person input, or the user. It's powerful for sequencing. Okay, for genomics generally, so something like this. And so we save this. We make it executable. And so we run it. Okay. Either use bash or the dots. So it's asking me to enter my favorite sequencing technology, and I go and be like Illumina or Nanopo or whatever. And it goes ahead to fill in the gap. So great, Illumina is powerful for genomics. So you can use arguments for if you have different sample names, or you have different sequencing files or sequence files. And you can also use, instead of hard coding file names, in the sense that you have to be stating, like typing out the file name itself one by one to run it. You can use arguments where you just be like, oh, just do args, or just do args, just run args examples .sh, and then instead of running the command for one item at a time, you can actually do a command that you can now list all the things you want to, maybe sequence 1, sequence 2, sequence 3, like that. So it depends on what's in your script. So it can be usable for whatever data set that you have. And then for the prompting, you can prompt the user for maybe a choice of a particular parameter, just like we have done here, like Illumina, and then It's useful when you're building workflows. So I think that's major for that is okay. Yes. So the script waits for the input before continuing, just like we saw there. So in this case, you read. So it says enter your name. You tell them the name, the age, and then it tells you hello, because the name the user puts is already stored in the variable name. The age the user imputes is going to be stored in the variable age. So you just get hello, the name, you are this years old. So that's for, so we can move to conditionals if or else. So every command in bash has a result. So the way the language is like, if it's zero, it's successful. If it's not zero, it's a fail. So non-zero can be 1, 2, 3, 365. So far it's not zero, it's a fail. So it's just like, if the rain is falling, or if rain is falling, take an umbrella. And if rain is not falling, don't take umbrella. Something like that. So the basic syntax of is for conditionals is, if, okay, I think I'm already jumping to, so let's just take it in order. So you use echo dollar question mark to check the last command's exit status. And so if the command you run is successful, you get a 0. If it's false, you get a 1. For example, okay, let's just quickly do, so if we say true, right, and we say echo dollar question mark, gives me 0. And if I say false and I ask for the exit status, I get a 1, because of course false is not true. The true is like a 0 success, and false is non-zero. So that's just what we have here. And then we now have this conditional execution, where the second command runs only if the first succeeds. And then the second command runs only if the first one fails. So, okay, so we have true. If it's true that you have a 0, it's run, or it's successful, you echo success, so it will print. But if it's false, it won't run, because false is not non-zero. Okay, as we have seen, and then you won't even get this echo fail. So instead of speaking Chinese, let me just show. So if I say true and echo success, right? It echoes it, because true is 0, as we have seen here, and then that means the second command will run, because it is only if the first command, that is true, is successful. So, and if I use false and I do and echo fail, right? Now this will not run, because the first command was not successful, or the way the computer or the program sees successful is in terms of, is it a 0 or is it a non-zero. So since false will give you a non-zero, to the computer it just shows that the first command did not run, so the second command will not run, because the first did not run. So that's like for the, when you have the and operand that is represented by these two and symbols. So you have the or, where the second command runs only if the first one fails. So, and then we have this example of is false. Okay, so we have false. Then we use our two pipes, and then we say echo over. Right. So now what does or do? The second command runs only if the first fails. And what do we consider as a fail when it's a non-zero? So we're supposed to see it's supposed to run. But if the second command will not run in the case of or, okay, if um, the second command will not run if it's true. So I'm not a liar. So the same will not run. So that's for that. And I guess a better example, let me give a better example so it to be um, cemented. So let's say, okay, if I say, I mean, we all know how to create a directory. Let's call it test directory. So I don't know, use if you so make directly directory and echo. Why did I keep writing echo? So an echo directory created successfully. So what's going to happen in this case? Remember, when you're using the and, the second command only runs if the first one is successful. And we already know that success is 0, or if the command runs. So we now have, so the second command ran because this directory was created. And if I ls, I should probably say directory. Yeah. So this is test directory. So it was created. Now, if I run this command again, it's not going to run because the directory already exists. So if I do that again, remember the condition is the second command only runs if the first one is successful. So I didn't get directory created successfully, right? Because that directory already exists. So nothing was created. It is just nothing was created at all. So that's why it's the same command, but because this already exists, it was not successful. So the directory created successfully did not happen because it was not successful. The first command was not successful. Now let's try using something with for. Okay, let's say ls no such file .txt. I hope you remember what ls is. And then we do an echo. Say echo that file doesn't exist. Okay. So remember what happens with or. Or the second command runs if the first one fails. Okay. So are we expecting this one to run?
Yes.
Yeah. Thank you. So because there was no such file, there's actually no such file here that bears that name. So just like you said, because the file doesn't exist, because the first command did not run, the first command was not successful. That was why the second command ran. So that's how. Yeah, I think that should be okay for the conditional. So we now move to the if and the else. We already established that every command in bash has a result. 0 if it's true, 1 if it's false. Just okay. So common conditions here, they're trying to check, does this your variable they are calling, or do these two items today, are they the same? Are they equal? You want to check if a file exists. You want to check if it's particular number that you have stored into the variable num is greater than 10. So this is equal to, this is not equal to, this is greater than, and then this is less than, and then this is greater or equal to, and then this is less or equal to. So let's try some examples with that. So let's check if a file exists. So we can do nano file exists. So let's find so if so you can actually use one curly brackets or two, but let me follow what I put on my material. So, and then remember the F flag is to check if it exists. Oh, I didn't even check for what I have. Okay, I'll run it 2 times. I'll use an example of a file that actually exists and a file that doesn't exist. But let me put one I know that doesn't exist. So data.txt, okay. It's good practice to put your I like this, your item in quotes. You can actually run it without that, but sometimes if when you're running in bigger programs or a bigger script, there's something they call plugging, and then you'll be seeing errors. You don't know that it's because of you didn't put quotation mark. So and then so if the file exists, echo data.txt is present, right? Else echo that data.txt is not found. And then you close that with the opposite of if fi. So I save, let's save it. And now I make it executable plus. Okay, so if I run this file, I mean, quick explanation of what it does is that it checks if data.txt exists. So if it finds data.txt in my current directory or the part that I specify, if I don't specify a particular part, it just works within the directory I'm in, which is bioinfo2. So if it finds it, it tells me it's present. If it doesn't find it, it will tell me that it's not found. Okay, so and I can run that. And I actually do not have anything that is called data.txt. That is why when I run it, I get data.txt not found. But if I use an actual file I have, let's see, let me use demograph. Let me use hit 26. So nano. Okay. And I want to edit it and I want to use hit 26. No txt. Okay. And I save it and exist. And if I run it again, oh, I didn't change. So it's present. So let me. I didn't edit this one too. Yes, 26 txt. Hist 26 txt. Okay. So because I have the document here, so it checks my current directory and sees that the file is actually present. So you can use conditions to check if something is present or not. Like for example, if the file exists or not. You can also use it. Okay. Does someone have a question? You can speak.
Yes, I do. So, okay. I wanted to ask if it's possible to like make the file in a way that you can just put the name of the file you want to check and then to run it instead of like editing the file for different like file names.
Okay. We covered can use arguments. Okay. I
Okay.
mean, you can use. Remember when we treated argument under variables and input. So if I make this, okay, and I go and be like file, right? File equals $1. So if file, okay, so in this way. So if I do,
You have to change. You didn't edit the file
what do you
format.
say?
Say you did not edit the nano file. So in those
Oh,
echo,
yeah, yeah, yeah. So echo, that's the file is present. Right? Mm, echo that this is not found. So yeah. So let's run this and let's pick. Okay, let's use our data.txt. So that's an argument. That's the first argument. If you remember when I was talking about variables and input. So data.txt is not found because I don't have that. But if we try running that again, it's arithmetic.sh. Arithmetic.sh is present. So you can see that you can do that. Adiola, I don't know if I
Yes, it's
was
very
this what you
clear.
asked
Thank
for?
you. Yes, yes,
Okay.
yes.
Okay. So yes. And aside from checking if a file exists, you can also check um if a number is even or odd. I think maybe if you're doing a sum in your data analysis and how would that work? But you can check if you have an even or odd number. Okay, let me try to create something that will be script creating. Nano even odd dot sh. Okay, then we go something. So if I want to ask somebody that they should input a number and I can guess if a number is even or odd, well, this use case is maybe if you are doing any programming sort of thing that requires someone to put a number or the computer to calculate something to get a number for a specific input or a specific output to be given. I don't know how to give this example, but let me just try something. So if I ask the user to, let's say, give me any number in this live, so enter number, okay. Don't forget, whenever you're using the um, P option, make sure you have a place where you can store the inputs that you get. So let's call that num or no. Okay, and then we now say if if num is divisible. So if we use percentage to do division. No, sorry, modulo. So if the number is divisible by 2, you automatically know. So modulo is if something is divisible by something, your answer is the remainder. So if it's divisible by 2 and it has a remainder, you know that that thing is not even because the remainder will be 1. Okay, I don't know if that makes sense to you. So the number divided by 2, okay, is it equal? If it's equal to 0, now this is a condition. If it's equal to 0, then echo that this number is even. Okay, and then else echo that the number is odd. So, and then you close your conditioning with the opposite of if, which is fi. So what this does is, if the number is divisible by 2, and then the remainder is equal to 0, because that's how modulus. I don't know if you remember how modulus in mathematics. This is not division. If you want to do the division, you use slash. You use this. So what does it? So if you pick the number that the person supplies, right, and then divides it by 2, if the remainder is 0, so that means 0 is equal to 0. So that means 0 equals 0. Of course, that is true, right? So if it's true, it runs the first. But if it's not true, that's why the else is else, and then it tells you that it's odd. So in bash scripting, you will probably hear this much more explanatory eventually. The way bash works is that it reads each line accordingly. It does not assume, it does not jump. Even I think even Python to do that. It just starts, it reads the first line, goes to the second line. So it's only if this condition is true or false to now do what you want it to do. But if you find out that in this case it didn't get a 0, it's got a non-zero. Now I'm not talking about 0 here. I'm talking in terms of 0 true, okay, non-zero false or fail, right? That's if it gets a 0, that it's a true or a successful, it runs. That's why it's then do this. But if it does not get a true, if it gets a non-zero, it does this. It gives you the next thing on the line. So we'll check it out now. We'll see how that will work. So I have to make it executable. Okay, so even. Right. So let me use this with even mode. So it asks me to enter a number, and then let's say 789, which we already know that this is not an even number. But then because of the way you've programmed the script, it knows how to give you the answer. So it says 789 is odd because by the time you divide 789 by 2, there's no way you don't have a remainder of 1, and 1 is not equal to 0. So you now get this. But if you do this and I put 6, 8, 4, 4, 4, 4, 4, 4, 5, 2, because it's an even number. So I think that's, then you can also do something like another condition example with it. Let's see. This one you can actually run it by yourself. You can run this one by yourself. So this one just checks if it's 5 greater than 3. If it's greater than 3, echo yes. So just the same thing as the first command is successful, the second one runs. Okay. Mm. So this is if, elif, else. So when you're doing conditions, you have, I mean, just like we saw, I used just if and else. I didn't use elif. So if you have a command that asks for, if you have more than one condition that you want to query, okay, you can speak up.
All right. So please, I don't know if you can use an odd number because I tried it and then it still came out as even.
I used an odd number. Okay. Give me, I don't know, give me another number.
Okay. I use 9.
9. 9 is odd.
Yes. Ah. Okay. Let me check again.
Did you check your script? Check the script you're using. Because the only way you get something like that, check your script. Is it the same as this? Or did you type it out on your terminal? Because if you type it out on your terminal, it will only run, it will run the two of them at the same time. You can cross check the difference between this one and your script too.
Yes, it's the same thing.
And you got even for 9.
Yes.
Can you put your code on the chat box that you can see?
Or if you can screenshot and put it on WhatsApp chat so someone can, maybe they can look at it and can just screenshot it and put it on WhatsApp. Or you copy it and put it on the chat of Google Meet.
I think it has to do with the if part. I think I should have used amount instead of num.
No,
Yeah, exactly. Yeah.
it doesn't matter. Except if it's the capital letter. Change that your capital letter A to small letter A.
No, I think it's because you used num. Like it's not recognizing
It doesn't matter.
the input.
No, no,
Okay.
no, no.
Just
I
change
think
your
no. Sorry. I think Adiola is right because if you look at that if statement, I mean that if
It's
line,
working now.
they say norm, but it is amount that you should be putting there. Amount
Yes.
percentage
oh
if
okay, okay,
equals
oh,
to
oh,
cost
oh,
as
oh.
well.
Yeah. I've
It's
changed
here.
You
it
have
to
to
amount.
write.
It's working. Thank you.
Okay, yeah. So
Okay.
nice catch, Adiola. Nice catch.
Hold on.
She didn't see the number there.
I didn't even see the no. I just saw amount. Okay.
No man Victor. Victor is a fraud.
Maybe you were copying it directly. Okay. So let me see the examples I put here. So if elif comes in play if you have more than one condition. So maybe in this case you're like, so if this condition, you know, if what you're asking it for meets this condition, then run this command. But if it does not meet, it will go to the next line. Okay. And so you now have another condition. And then if it meets that one, it goes ahead to put it the whatever command you're telling it to do. And then if it does not meet the first two conditions, that's where you now have the else and then have a default. So you can have as many elifs as you want. So it's just that make sure your elif is in between. Okay. And okay, this is an example here. So in this case, we have if $1 is equal to 4. then of course we know that in this case, that means if I run the script and um, I put 4, okay. So that means if what I impute is equal to 4, then right, you entered 4. So it's like a guessing kind of thing when somebody say pick a number in your head, but this one you type it. And then this one says if I supply a number, okay, if what I supplied is not 4, let's say I supplied something greater than 4, okay. So if it's wrong to, let's say I supply 7, okay, I will now to go to the first line, say no, it will not run, it will not echo it because the first condition was not met. It goes to the next condition, which says that what I impute is greater than 4. So, and I said 6, or was it 7? Anyways, either of them is greater than 4. So then it will now run greater than 4. But if I put something like because if I put 20, it will still be greater than 4. But if I put something like let's say 2, it will now be like, it will now echo other number, because 2, number 1, is not 4. So the first condition does not meet it. If 2 is not greater than 4, so this will not come out. And then this else is like anything else that the person puts, just so far it's not these first two things that I want, just tell it to echo other numbers. So I think it would be nice if I put the script here, just the create nano what are we trying to do, say guess number, let's see. Okay, we do hash USR. Okay. I say if $1 is equal to, let me use the is equal to 7. Okay, then echo number is equal to 7. Elif. Now, you know why I'm using elif, because I want to do more than one condition. So elif number 1 is greater than greater than 7. You can actually change this to something else, so but that would not make sense unless you are trying to probe and probe and probe till you get what the person. I wouldn't want to even try to do that kind of thing. But let's just continue. So then if it's that, then you echo number is greater than greater than 7. So, because you know that instead of using number, you can actually use. Since remember when she asked if we can make it non-redundant, you can actually either you go and be like either you go and be like $1 is greater, or instead of it saying number. Look, so wow, or $1 greater than 7. So then else. Okay, let's try something that let's do less than elif. Okay, elif $1 is less than 7. Then then echo is less than 7. Then oh, okay, I did. Yep. So else is definitely not a number. So else echo, it's not a number. $1 is not a number. Or is it numeral? It is not a digit. Because you can write number in words. It's not a digit. It's not a digit. Please provide a digit. Something like that. So then don't forget to close with the opposite of if. So we do, we'll save it. I have to make it executable with plus X and yes. Okay. So if I do guess, then I give it 97. Because 997 is greater than 7. And if I say 7, if I say 7, right? 7 is equal to 7. And if I give something lower than that, if I give something lower than that, let's say 3, 4, then that's how is 4 not a digit? What did I do? Let's look at what I said L if $1 is less than 7. Oh,
I think it's from the spacing. So there's no space. Your code is right. There's a spacing between the $sign and the $1 rather. In your second elif statement.
let's try that again. If 4 is still not it, okay, so 4 is less than 7. And then let's put something that is not a digit, and then go and be like oranges. Yeah, oranges is not a digit. Please provide a digit. So I hope we get the idea of conditions now. Yeah, there are different. You can use it in different use cases. Actually, you can. I mean, there's something we call quality control in bioinformatics. You can, for example, there's a tool called Triomatic. So you can be like, oh, run. Let me just use quality. So run quality control, for example, for QC, only if the file exists. So something like that, it look like it means you are going to check for the file first, and then the next command will be running that quality control on it. So it looks something like, I'm not creating this. So let's say we're trying to run quality control only if that file exists. If the file doesn't exist, we escape, or we I mean, it can tell us, or we log it into a log file, such as I think that's where you can use it for error handling, or to document. Okay. That sound.
Sorry, please. The last code, I didn't really get it. Like the then one after the secondary leave, because it's not working. It didn't work on mine.
Which one didn't work? All of them or a particular one?
The
You may need that
else,
over time again.
okay, $1. Okay.
Have you seen the error?
Yes, yes, I've seen it. Thank you very much.
What was that? What was the
Like I did not add the dollar to the last line of code. That is the after the else. I didn't add dollar. One is not a number.
And why
okay?
will you forget the dollar? And you want to be
Because
rich,
that's what we used to call it.
Victor, and
You
Yeah,
cannot
thank you.
call yeah
you are forgetting dollar.
of all the
Please
things to
leave
forget.
Victor alone for me, Jai.
Okay. So like use case in bioinformatics. So let's say you want to check if the file exists before you run a particular quality control. So you can have something like the first command will be to check it if it exists. Okay, so like if your sample and sample could be in no, we use FASTQ for that. So FASTQ, let's say it's compiled or it has a zip in it. And then we be like and let's say FASTQC, that's the command name. Or eventually you understand what that is. Sample dot FASTQ dot bz. So I'm trying to combine the two together. And then you have echo um, um fast q is missing. Okay, and then it's shouting back at you. So what will happen in this case? It's you can combine both the and the or. So in this case, what happens is here the condition is checking if the file exists. So if the file exists, we know that the second command will run, right? So that means the first QC will run is an actual command to give us the quality control of whatever sample or faster fast queues or GZP is. But if this file does not exist, if this file is missing, of course we know that this one will not run. First QC, the command, the program, first QC program, there won't be any quality control in anyway. But because this guy will run if it fails. So you will now see Pascal is missing. I don't know if so this kind of thing will tell you that if you have like 300 samples and you're trying to run Pascal C on all of the 200 is even small. Let's say okay is one okay, let's use 300. And then for each of them you have in your code, you put something like this, you know how you adjust it. Because maybe instead of sample, you use dollar or you use a regular expression. Let's say you do something like star. So you just know that in your folder, anything that has this FASTQ, the extension FASTQ.gzip will run. And so then in your so this checks if it exists, and then it does FASTQ for those ones that are present, those ones that you have, for the ones that the file exists. But if the file does not exist, how will the file not exist? Okay, if the file does not exist, okay, this one will now tell you that the FASTQ is missing. Okay, maybe not in this instance, but maybe you could list out different, maybe sample one, sample two, something like that.
Well, I
So
think it's still going to work
okay.
with
So
that
what
style.
happens is if those samples are present, the FASTQ will run, you get the quality control checking. But if is that particular file or the files are not present, it tells you that the FASTQ is missing. But of course, you know that if you're working with a lot of things, you know this is not the error message you put. You will tell it, you change it so that it gives you the name of that particular sample that is not present. Something that would say with that one. Your okay. And then it's actually really one condition for checking if today is a particular day. Okay. That one is for another. Let's go time. So if this is this, then is it this? Is this? Oh, we have nested example. So what happens in the case of nested example is that if you run this one is like this will actually be one that would be called when it's trying to guess the number. So what happens in this case is that okay, if you input a number, let's say I say 4. Okay, what happens here is that is 4 less than 10? Of course 4 is less than 10. So yes, then it goes to the next command. Now nested in the sense that this if it's not what do we call the line? Is indented, which means it's so it runs if this first one is true. So we already established that 4 is less than 10. Okay, then it goes to the next one. So is that 4 still equal to 4? Then you cannot echo 4 and then close and all of that. Hope that makes sense. Then what's okay? So array or arrays. Any question? I think we've even gotten to where we have very elastic. So for arrays, array. So let's say you want to store multiple values, like maybe a lot of fruits or a list of fruits, or you have maybe a shopping list, or maybe different file names. We've already had experience with arrays already, but you know, we just properly talk about them now. So it's a variable that holds multiple values that are accessible by their index. So Stooges is an example of an array. Is it Corley? Is it Larry? Is it Mo? Then array index starts at 0. Let's see how that works. So if you want to access an item in an array, you call it. Don't forget your dollar sign. Don't forget dollar. Then you open your curly brackets. You put the array. Then you put the index. Okay. So if you put 0, it calls the first value. Okay. It calls the first value. Yeah, that's the word. It calls the first value. So that's why curly came out. And if you want to call all the items, you use the @ so it will now call curly Larry Mo, one of them. So if you want to define an array similar to an array is a variable, so it's just that it's multiple values. Okay, so we have names equal to Alice, Bob, Charlie. All the colors I could find, I chose green. That says a lot. So we have Alice, Bob, and Charlie. Or you can actually build it step by step, where you be like names, 0 index is Alice, names, number 1 index, which is the second item, and then the third item, which the index number will be 2, is Charlie. Then using array, I'll do proper examples. Using arrays, you print specific elements. So you echo, just like we said here. You want to collect something or you want to get something from your array. So echo, use the curly brackets, the name of the array, and then the index of what you want to remove. And then you can also loop over array. We'll talk about loops for that. Yeah. So I think of 20. Okay. So for name in names. So for name in the whole everything that's in this array. Okay. Do echo hello each name. So if you run something like this, it goes and be like, hello Bob, hello Alice, hello Charlie. But let's try Let's try an example. Hmm. Let's do fruit. Fruit, 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 fruit. And yeah, like apple, banana, mango, and lemon. And lemon is okay. So you just created an array. So once to access it, you access using what? You call it with echo, you access it with the dollar sign. So let's make it a bit dramatic. So let's say echo first. I want the first fruit, right? I want the first fruit, and then I go and so it's now I want to do the proper accessing, and then I access with my dollar and my curly brackets, right? And then fruits, the name of my array, and then I go and be like, I go and be like, okay, let's say first fruit, so the first one, and then I close it with my curly brackets. I won't forget this. Yeah. The first fruit is apple, and then you can change that. -1 starts from the back. Just give me the last one. But if I don't want to use -1, maybe I actually want to call it 3 is lemon. Lemon is the fourth item, but it's 3 because indexing starts at 0. So don't forget that. So if I want to do a looping, okay. So let's do small loop. I'm not creating script. So for F or for fruits, let's use something. So F in okay, access. I want to access my array. Don't forget curly bracket fruits, right? And box. So what do we use to call all of them as the art? The art will pick up all the items, all the values in your array. So that's where we have the at. Okay. And so I want so for F or for I or for anything. So it's just like for one item in this basket. So one fruit in this fruit basket. Do so I'm using the terminal. So do echo. What I've used. Okay, so echo. I like dollar F, right? And close bracket. And then done. So when you're using for loop, we talk about this properly. When you're using for loop, you end it with a done. When you're using if, you end it with a fi. So done. Okay. Okay, the indent. You can't get it here. So I truly have to use. So nano fruit basket. USR. So for fruits in like to pack everything together. Dollar, then fruits. At do echo I like dollar and on. That sounds good.
It should be dollar fruit, not dollar F.
Hmm?
It should be I like dollar fruits. Mm. What's like that
Right, right.
equivalent?
I want to see if it's able to access the fruit variable at the array that I put in the
Yeah, to be able
white.
to access it.
Okay, so and then I make it executable. Mode plus X, then put baskets. So if I run that, it didn't get it. It didn't get it. Now let me just put tomato in it. Need to run it again. Let me clear this message screen. Okay, so what happened in this is that um, okay, so I gave it an array and I said for each fruit in this fruit basket here, echo I like picture. So this is what a loop is. It iterates, no other word, another word for it. So it picks each item one by one, one by one, one by one. So for each item, you will do everything that is within this command till done. Then you now go and take the next item. So it will stop looping after it has done the last item. So I think I'm already explaining loops. So that's what happened here. That's why when I run it, it's like accordingly. I like apple, banana, lemon, orange, tomato. So that's how you can use arrays to loop. You can loop how you can loop over arrays. And then you can actually yeah, you can say what you want to.
Okay, so before you like the first script you wrote, like before you went on to specify the array inside the script. So I was like kind of wondering whether you wanted to list that particular array like after calling the script instead of having to specify it within the script. So like you just say you call the scripts and then you now write whatever fruits
Like in
or
front of it.
yeah.
That would be
I was hoping
using
it would be,
okay.
I
Let
don't
me
know.
try an example. I can try an example with that. But what I was looking at was that the first time was if an array I created on the shell, like on the terminal, if the scripts can access it. Okay, I've forgotten where it's been stored, where you do arrays and variables. I was thinking it would fetch if it were universal, then it could have fetched it. Well, I can try what you said as the
But
Hmm,
the first one you made, was it saved? Because I don't think it was saved as of then. I'm not sure. Like
it was
the one you made on the terminal, the fruits are
and no, that's what I'm saying. The one I made on the terminal, it was saved, but because I can check it here. See,
okay.
so
Thank
yeah. But for the one you say using arguments like looping, that's a combination of array with looping and then arguments. So I will have to edit the fruit basket. So I feel like fruits equal to dollar. Is there a way I can clump this instead of writing $1, $2, $3? $2, there should be $3, $4, 7.
But can't you just put probably dollar at
Hmm?
dollar at sign? You know, initially you told us that you can actually use dollar at to get
Oh
all of the
yeah, yeah.
arguments in the pass. I'm not sure if that is going to work in
But let's
this
let's
instance.
let's see if that will work. Let's just use fruits equals $1.
Yeah.
Something like that.
Yes.
I didn't hear what you said.
Yes, yes, yes.
So I'll now be listing all my Apple. Oh no, no. I couldn't get now. Range 4. Okay. Fine. It took everything as is a script. Maybe because I didn't separate it. It took everything at once. Let me just use. Okay, I can't hear properly. Is it my network? Showing that is one. Okay.
And you probably put that one inside squared, I mean the dollar at inside a round bracket.
Is it okay?
No, 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 no. No, before the dollar. Yeah. Then close it. I've never tried it before, child.
Hmm. Wow.
Like for example, it
It,
works
it
now.
actually works when you put
Yeah.
it inside.
Okay. But then, like for me, when you are trying to make it in the first place, like the one you wanted to do initially, like I was like thinking
Hmm.
from the angle that you don't even need to specify any variable name. Like let's say for example, you can go back to the scripts. Maybe what I was thinking, like I was thinking of as of then. So without having the fruits variable at all. So then instead of having the array, like you can still go back
Is it
to the
with
script.
it?
Yeah. So on the first line of code, like the first four, yeah. So just remove everything and leave just at dollar at.
Like this?
I was hoping this would also work.
And that means I will call it. I'll have to call it. It will work. It should work the same way as this one. Yeah. Okay. I think that's faster.
Yeah.
Yeah. I don't know the use case, or but just to emphasize that. And then another thing. Let me see. Looking over it. Advanced operations. I don't even know why I put this here. But we can, I think, can show if you want to get the length of an array. Let's say you have how many? What's inside our fruit basket? Echo. Yes.
Okay, yeah. So when you talked about, I just want to maybe chip in something. Don't mind before we kind of
No,
speaking.
it's good.
So you talked about like maybe a use case of like what Abib and I should. So
Mm,
let's say for example you wrote a script that is meant to maybe work on some files, maybe TXT or FASTQ files and the likes, and then you want to pass it to specific maybe genomes or files of your choice. So you can like this can kind of serve as maybe a use case. So you write a script that performs a particular maybe task on some files. So all you need to do is once you write that script, save the script and then indicate the particular files. You can either use wildcards or you specify the individual files that you
mm,
want it to work on.
actually, and I think another use case would be, let's say you have a text document that have like maybe a lot of samples, or even this maybe all the foods we have in this life, and then instead of typing out apple, banana, orange before, you can actually just call that .txt file that has maybe all the ascensions of your samples that you want to iterate over the command, or even just simply this, and then to list all the. I don't know that I get what I'm saying.
Yeah, sure.
Yeah. Okay. I think another thing you can do is to check the length of an array using the hash or ham. So we've already seen how is Apple the only thing in typeface.
I think it's because you didn't put curly. So if you want to access an array, so you need a curly
Oh,
bracket, and then together with the at sign
yes, yes.
inside the square brackets,
I was calling it like a
a variable,
yeah.
and then so you need the at sign as well inside the array. Yes.
So when you're calling a variable, you only need echo with your dollar. But when you're calling an array, you have to call it properly with the curly bracket. If not, it will only bring the first item, the zero index item. So you can also know the length of your array. You make use of so let's say we had more than 5 items in our array. We can actually do echo number of I think after this I should skip so that we enter braces. So use the hash or the pound sign, and then you select all the items using that. Then you close it. Oh, they're taking it out. And then you use this. So what happens here is you told it to, normally if I didn't put this hash, to just give me all the items. So the hash is for all the values you have in your array. And so this hash is like it counts all the values in your array. So what happens here is because if you do this, you will not get answer because what was that use? There was one use case that we did where it involves using a loop and you have to access. We used it to. Okay. So you just remember that the hash is just for checking the number of values you have in your array, and then the at is for the entire to call out the entire values that you have in your array. I think that's that one. This is my phone. So for next thing, so bash arrays are one dimensional. There are no built-in 3D arrays, but you can fake them with tricks like indexing, index naming. That's where you make use of either calling it with a number 0, 1, 2, 3, 4, minus 1, minus 2, passing from the back, or string passing. So arrays store multiple values under one variable. We've seen that. Okay, how where we saw fruits and then we saw different things. And you use dollar, the array, then the index. That's 0, 1, 2, 3, 4, 5, 6, or at to get everything. And then you use loop. You loop using for or for like our for fruits in fruit array for indexes. So there's length, slicing, and you can delete items from your array using onset. Using onset. I don't know, should I demo that too? Because of time. Okay. So we in the previous listen we had these names, okay, and then so what happens here is, as we've seen, we get a number of items in the array or number of values in the array, like how we got number of fruits equals 5. So we loop. We've seen how to loop. So echo name $I. Of course, you know $I means you are referring to one item in your array to give you the so it's like saying if you say to $I will be like, okay, name, so Alice equal to Alice index 0, then Bob would be index 1, Charlie index 2. So that's just what that. And then you can use onset. If you use onset, remember the Bob has an index of 1, so if you use onset, it deletes the item. So let's try using onset. So we already know what's it's inside our fruit. Okay, and if we say onset fruit, and then we use the index, who should we remove? Mango. Lemon. Okay. And so we call thank God. That's the disgrace. So the lemon has been removed. So use onset. Then you can do, we call this slicing. So from index 1, you get to two elements. So let me just use this our mango. So we have echo. I don't want to type again. Okay. So yes. So what happened here is that we call it, is it slicing now? Yes, slicing, where you pick a particular amount of items in your array. So we know apple is the first, banana is the second, mango is the third. So index 1 and index 2 will be the second and the third item. So tell it to produce the second and third item. You will tell it to give you, what did I do? So it's going to bring the item with the boundary. So these are your boundaries, the upper boundary, the lower boundary. So it brings the values between those two. That's why we have, and don't forget, index 1 is your second item, index 2 is your third item. So the values including and between 2 and 3. So in this case, you have, give me the values that are among and equal to, between and equal to the second and then the fourth. Yeah.
So, okay, just to probably buttress what you said, basically what that particular command is saying is, okay, give me 3 items starting from index number 1. So basically, that's what it was saying. So give me 3 items starting from index number 1.
I can't hear you well, Abib.
Hello, can you hear me?
Yes, it's better.
Yeah, I said just to buttress up. So that last command that you ran, that echo fruits colon 1 to 3. So it's basically saying, give me 3 items from the fruit array starting from index number 1. So, and then it's going to go to the starting point, which is index number 1. And index number 1 is banana. And then it's going to like start giving, I mean, it's going to like give you three items starting from banana. So banana, mango, then. So that's why.
Yes, I think that's better. The starting and then how many things you want me to do from that starting point.
Yes. Yeah, exactly.
That's better put, sir. So yes, that's just for braces and loops. So for braces, we have they're used for grouping commands. It's not common, but has its valid use. And this one's multiple command in one block, often used for redirection. I don't think I've even ever tried using something like this. So instead of saying, because if I write echo start, echo end, just like that on my terminal, echo start, and I say echo end, see what happens. It just took, it was only the first echo that was recognized. But by the time you make use of the grouping to separate the two commands that you want to write or you want to use, or the 3 or 4 or 10 commands that you want to use. So if I use my braces, I'm going to be lazy. So to separate them, and then brace. Oh, okay, braces. And then I forgot this. So the braces, and then to signify that that's where the command stops. So this arrow here was telling me that I'm not done because I didn't stop what came after end. So that's where grouping commands, what braces are used for. Then you can also use braces for expansion. We've seen this when when you're trying to
White cards.
yeah,
Is it white cards or
yes, well,
just like
where we had, if you want to say A to Z, or you wanted to select items that begin with A to Z, or if you wanted to take a number between so a within a range. So brace expansion just generates sequences of strings. So it's a shortcut of writing multiple times. So if I say echo file A, B, C, I'm sure somebody give example of this. So it will give you file A.txt, file B.txt, file C.txt. And if I say echo 1 through, instead of saying echo to numbers, I just say to echo what is within this range, and then it will give me 1, 2, 3, 4, 5. Okay, so that's that. So it's just a compound kind of thing for what we've been doing. So loops, I've already introduced you to loops. So loop repeat sections of your script. So this is for automation. Okay, don't forget that one of the nice things about Bash programming that is beautiful for automation. And then as well looping, you will see loop in different programming languages. So what happens is that there's two different types. There's the for loop. You've not seen me use while loop. I think that would be the last thing then you can take functions, and functions will be all. So so what happens in the for loop is that it goes through a list or a sequence, and this loop runs until the last list is exhausted. Just like I mentioned in the case of mango, where we're like, I like apple, I like mango, I like donut. Okay, donut is not a fruit, but you get the point till it gets to the last fruit, and then so and instead of if you have a number and if you have a an alphabet, you can also use the braces together with your for loop. So it's just like you can use the examples together, and then you tell it to echo item, and then you hear, okay, let's I think I can try this item one, item two, item three, but it's similar, like that's the same thing as I like apple, I like mango, I like orange, example that we use here. So let's clear how many. I want to see how many. Mm, okay, because I don't want to create script. I no items data switch. User doing that. And full item in our curly braces, and I want you to help me to do it 10 times. I want to iterate over 10 items, and then I tell it to do echo echo item dollar. See that these two items are not the same. Don't make sure I know when you're using it, because if you put it the other way, you just be like 10, okay, 10, 10, 10, then okay, let me just run this one. Item, then item, okay, then done. Think open up. That's nice. And so if I again one X items message, okay, and I run it. I think it's message. So just like that, I like. It makes everything because I told it 1 to 10. 1 to 2 item, 1 item, 2 item, 3 item, 4. It's just like that. So other ways to generate you have for X in red. So this one is like you're stressing yourself to list out what you want for X in red, green, blue, and then you can use an array. So if colors, we use fruits, remember, for this, and then we said for C, like we said for fruits in fruits. I hope you remember this. Then remember we can do the video, and rewind the video and see where we did it. Then for command substitution, for file in dollar ls. So what this one is like, in your current directory, you're trying to loop over all the .sh files that you have. You want it to sh loop. You want it to. So what happens is it lists all the .sh files, and then it takes each of them as a file. Let me see if I let me run this. There's my snap. Okay. Oh, I did not tell you what to do. Control C. I don't want to create another. So what can I tell it to do? I don't want to. But the idea is for each of the files you have here, sh. So it's what to do is to list all my .sh files. And so whatever I tell it to do, the next command after the for, it will now be like it will now do each of those commands on each of the .sh files that I have. I hope I haven't forgotten our wildcards. No. Okay, while loop. Okay. So while loop it runs while the condition is true. Okay. So it repeats based on a condition. This one runs until the last list is exhausted. So while a particular condition is true, it will keep on running until it reaches a false. Now you have to be careful, right? I don't know if you code in any other language. There's always this while, right? You have to be careful for because the while loop won't stop. It won't stop. It's not. It doesn't. It won't stop until there's a wrong, there's a negation, there's a false. So, and that's what we call infinite loops. You will just see that a particular command is running on your system, and if your RAM is not good, it may just, I don't know, crash and all of that. So be careful. Infinite loops happen when the condition never turns false. Never turns so and if you find yourself in a situation when your code is running, it has been running, you can just use Control C, which is what I used to stop code, or people use, anybody use. So in this case now, we have count equals 3. Now, while the count is greater than 0, continue to count. So let's count because to count from this one. I don't want to create. I want to create a script for this. And is it okay if I take while loop and because I'm looking at the time and then we finish.
I
Yeah,
actually think
probably we
probably
should continue tomorrow.
yes.
Okay, because
Do you agree, Abi?
Yes,
it's
I agree
just
because
function, just
I feel like they need to digest. Yeah.
okay.
But please, can they have the video ahead of tomorrow's class? Tochukwu? It's like not all
Yeah,
of
like
them.
once we are done, like probably like in an hour from now, you can check the calendar. It should be there.
Though some people complain that I mean the quality of the recording on the calendar is not usually good. So
Oh, okay. Like once I get it, I would upload it to YouTube.
is it possible to that YouTube stuff?
Yeah. Okay, so
If it's
Marina, that
because
means you can finish up full bash scripting by tomorrow, right?
Yes, it's just only functions left, and maybe we'll do
hello ma.
the best practices
Okay.
and activities people should try, stuff like that. So it's just functions, and maybe if you take while
Okay.
loop because of time, you can take while loop and then functions.
Okay. So by progression, I'm guessing that if we are able to finish data analysis with Unix by next week, then we can have the test by upper week. I'm thinking because we don't have anything outside this that's outside bash scripts and the Unix beyond next week. So, because I think from upper week we should go into blasting and databases and the likes. Okay. Unless I'm missing something. Wait, to GitHub. I think GitHub should be next, right? I'll be after data analysis with Unix. I think so, yes.
Yes, it's
Well,
GitHub.
I don't. Joseph and I won't be available. So I'm thinking if it is possible to just probably start with Git. I mean, with GitHub since you'll be the one in charge of that. So
Oh,
I'm
you will be
traveling.
available next week.
Yes, Joseph is traveling tomorrow, for a conference. So he's
Okay,
going to
yeah.
bring. Then also me, I'll be traveling by I
Okay.
think next week. I think next week Friday, I think. Then I won't be back until September 28th.
Okay.
Yes,
Okay, then maybe I can also prepare for the Unix, or I can work with maybe somebody else to take the parts.
okay, maybe.
Yeah.
I can take probably the Git start when I'm back. Or you can also
Okay. Okay, maybe I will share the slide because I've already made the slide for that one already. So I can still share it with you too.
But if it is possible for me, I don't know the time difference between. Yeah. Okay, let's share
It's
it
all
with
good.
you. I'm
It's
not
all
sure
good.
whether.
So good. But then for the gates, I think it depends on whenever we fix the test do. Let's say we give everybody time to prepare for the test ahead of Oba, then we can have the gate class probably early October.
Yeah, I think
Because
the
we
gate
have
can
the
actually can
test
come
Oba.
anytime.
Yes, it can come anytime. Okay, so data analysis with Unix next week, then upper week we would have the tests. Okay. Yeah, thank you very much, Miranda.
Thank you, Miranda. This was so helpful. Well done.
Please, do you have questions for her before we round up? Or did everybody understand? Okay, you can
Thank
sit down.
you.
No, it's okay.
Thank you very much, ma.
You're welcome.
Thank you.
Okay, so good night, everyone. See you all tomorrow.
Yes, good night. Later.
So I would have loved to say something, but we are still on the recording, so I can't stop it now. Because I joined with my phone, so I'll just end the call for everybody.
Okay.